Hey everyone, so what we're going to be working on today is we're going to talk about cosecant and secant. How do we graph them and how are they related to things that we already know? So let's go ahead and start. The first thing that I want you to do is write on your screen that sine is related to cosecant. We know that from previous lessons. We know that specifically sine is the reciprocal of cosecant. So we can actually write cosecant in terms of sine. I know that cosecant of theta is equal to 1 over the sine of theta. Okay, so that's probably some pretty good information that we want to keep in mind. Some other information that I want to go ahead and put in is we're going to go ahead and use just like a graphing method to see if we can sketch what cosecant is going to look like. So we're going to try to use that. So let's go ahead and set up a three-pronged table. We're going to have theta in it. We're going to have sine, which is closely related to cosecant. And then lastly, we'll do what we need, which is the cosecant of theta function. Let's go ahead first. Before we start doing any of our table, though, I want you to practice. This is a good review. Go ahead and see if you can graph 2 periods of the sine function. Okay, so this right here is a pretty good sketch of the sine function graphed to 2 periods. And we're going to use that in just a little bit. So make sure you have that copied down also. All right, so what I want to do next is I want to explore what would the cosecant function look like graphically. To figure that out, let's go ahead and do some points in our table. We'll say 0, pi over 2, let's do pi, 3 pi over 2, and lastly 2 pi. So let's see if we can find the values for each of these. To do this, you might want to think about your unit circle, or you could just think about your sine function also, and that will also work. All right, so let's go and start with 0. I want to know what sine of 0 is. Well, according to my unit circle, the ordered pair at 0, 0 radians, is going to be 1 comma 0. And therefore, the sine of 0 must be 0. You can also see that graphically here. Okay, I know that 0 is the same thing as 0 over 1, and that cosecant is the reciprocal of sine. And so to find cosecant, I'm going to take the reciprocal, which would be 1 over 0, which we should know is undefined. When something is undefined, typically, just like with tangent, it's going to form some sort of oddity within our graph. In this case, it's going to form an asymptote. So let's go ahead at x is equal to 0, or theta equals 0. Go ahead and sketch an asymptote. All right, we're going to go through, and I want you to see if you can find what the cosecant and the sine values would be at pi over 2, pi, 3 pi over 2, and 2 pi. So go ahead and pause the video and see if you can do that. Okay, so you should get the following when you plug in. We should get undefined a couple more times, so let's go and focus on that first. If you plug in pi to sine, you're going to get 0. And if you plug it into cosecant, you're going to get the reciprocal, which is 1 over 0. And therefore, at pi, we're also going to draw an asymptote. Similarly, at 2 pi, we're also going to have an asymptote. In addition to that, let's go and talk about the points that are associated. At pi over 2, sine is 1, and the reciprocal of sine is still 1. So at pi over 2, we still have an ordered pair up at 1. Similarly, at 3 pi over 2, sine is 1, negative 1, and cosecant is going to be negative 1 also. So we can put a point also at negative 1 for 3 pi over 2. So you start to notice a pattern here. Notice how the asymptotes seem to be happening at every iteration of pi. In fact, you're going to see if you plug in, the asymptote's going to happen here, and an asymptote will happen here. And you also might notice that all the points seem to be happening at maxes and mins on sine. And that's actually I had to pause to think about that. No coincidence. That's no coincidence that is happening. In fact, there's something very, very, systematic about what's happening here. So let's go ahead and kind of formalize our thoughts. Here's what's happening. Technically, every time that sine crosses the midline, we get an asymptote. In fact, you can kind of see that here. When sine crosses the midline, cosecant gets an asymptote. So let's go ahead and write that. When sine crosses the midline, we can say that cosecant has an asymptote. Okay, so when sine crosses the midline, cosecant has an asymptote. That's a really good conclusion to make from this. One other conclusion that I can make is that when sine has a max or min value, we can see that cosecant has a point there. Okay, so those are two conclusions that we can make. Let's see if we can go ahead and connect this total cosecant graph. If you graph this in your calculator, if you graph more points, you'll see that this actually follows the following pattern. At maxes, we create this U shape that follows the asymptote up towards infinity. And when we have a minimum, we create this U shape that follows the asymptotes down towards infinity. And we just follow this pattern, like so. And so the total cosecant graph is actually just the blue graph. Now, don't erase this, but if you were to graph this on a calculator, you would not see any of the sine graph. You would just see the blue cosecant graph. And so that's technically the graph of cosecant. And so you can see how it's so important that you know how to graph sine, because sine is basically the cosecant graph, and then we add a little bit extra. Okay, so this process is going to be how we get the cosecant function, and a very similar process is going to get us the secant function. So secant function is going to be really similar. The main thing we need to remember here is that cosine is related to secant. So what I want you guys to do is I want you, to the best of your ability, go ahead and start graphing a cosine function, and I want you to graph it to 2 periods. Okay, so you should get the following graph. Make sure that you copy this down if you don't have it yet. You should have the following graph. This is the cosine graph. And so we're going to actually use the same conclusions we used last time to graph the secant graph. So the first conclusion that we had on the last slide was that every time sine crossed the midline, that the cosecant graph has an asymptote. The same thing's going to apply for secant and cosine. So what we're going to do is go ahead and establish our midline here. And every time I cross the midline, I should have an asymptote. So let's go and formalize that real quick. We can say that every time cosine crosses the midline, we can say that secant has an asymptote. Okay, so let's go ahead and sketch that. I'll do that in blue. So every time that cosine crosses the midline, which happens here and here, we can say that secant has an asymptote. So notice that secant's asymptotes are in different places than cosecant's. So that's something to keep in mind. One more thing that I want to conclude, which is the same conclusion from last time, we can say that when cosine has a max or min value, we can say that secant has a point there. So let's go ahead and do that. Every time cosine has a max or min, we can put a point for secant, like this. And then we're just going to follow the same pattern. Maxes are going to have parabola-looking shapes. They're not quite parabolas because parabolas don't have asymptotes. We're going to create these U shapes that follow the asymptotes. Down if they're a minimum, and up if they are a maximum, like this. And so our total solution for the secant graph looks like this. Okay, so make sure you have this. We are going to have a memory quiz on this probably later next week, so just kind of keep that in mind. I do want you guys to be comfortable with graphing secant and cosecant. All right, so let's go ahead and practice. Never mind. Before we practice, go ahead and write down these generic forms of secant and cosecant. Something interesting that I want you to note is that the period has to be 2 pi over b because we basically graphed sine and cosine. So secant and cosecant shouldn't have a weird period like cotangent and tangent. Their period is just like sine and cosine. So that's something to keep in mind. Okay, so let's go ahead and actually practice. All right, so we want to graph cosecant of 2x minus pi over 2. To graph that, I really just need to graph the sine of 2x minus pi over 2. So that's what I want you to try to do. Graph the sine of 2x minus pi over 2 by answering the following questions. What's the period? What's the quadrant? What's the amplitude? What's the vertical shift? And what's the phase shift? So go ahead and take a pause and see if you can figure those things out. Okay, so we should have the following solutions. We should have that the period is pi because 2 pi over b being 2, simplifies to pi. Quadrant is period divided by 4, and so the pi divided by 4, or our period divided by 4 is the quadrant. Amplitude is 1, there is no vertical shift, and our phase shift by some algebra is going to be right pi over 4. So let's go ahead and start with what's most important. The most important thing that we need to start with is the quadrant. To sketch the quadrant, just go ahead and use that as your scale. Pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is just pi. And go ahead and do the same in reverse. So go ahead and do the same in reverse. Okay, so what we want to do next is, while we're done with the quadrant, let's go ahead and jump to the vertical shift. There is no vertical shift, so I'm going to assume that the midline is the x-axis. So go ahead and assume that the midline is the x-axis. Okay, so we're done with that too. Let's go ahead and put a little check mark there just to kind of keep us on track. Okay, so the very last thing that I want to focus on then would be the phase shift. Typically, sine is going to start right here at the origin, right on the midline. But we need to go right pi over 4. So I'm going to do that. I'm going to go right pi over 4, and I'm actually just going to erase this point so I don't get confused. Okay, so then let's follow the sine function. Sine starts at the origin, or it starts at the midline. It goes up an amplitude of 1, so let's label this as being up 1, comes down to the midline, comes down 1, and comes back up, and follows this pattern. So go ahead and sketch that. Follow this pattern. Okay, so now that we have sine all graphed, we're actually almost done. We just need to apply those two rules. Every time that sine has a max or min, I'm going to have a point for cosecant. So go ahead and sketch a point at every max and min. We also know that every time that sine crosses the midline, we're going to have an asymptote. So go ahead and sketch an asymptote every time that sine crosses the midline. And then all we need to do is create those U-shapes that follow the parabola. That follow the asymptotes. And so we should get a graph that looks something like this. And this is the graph of cosecant of 2x minus pi over 2. Okay, so let's go ahead and move on to the next question type. The next question type asks you to find 2 cosecant of x plus pi over 2. So really all we need to do is graph 2 sine of x plus pi over 2. So let's answer the following questions and we'll be able to do this. We need to find the period. We need to find the quadrant. We need to know the amplitude. We need to know if there is a vertical shift, and we need to know if there's a phase shift. So go ahead and pause the video and see if you can find those things. Okay, so taking a look here, we should get our period as being 2 pi over 1, 1 being the b value in front of x, which means the period is 2 pi. If I take that value 2 pi and divide by 4, I'll get the quadrant. So our quadrant here should be pi over 2, or 2 pi over 4. The amplitude comes from the number up front here, and so our amplitude is 2. There is no vertical shift, and by algebra, we should get a phase shift of left pi over 2. So let's go through and check these things off. The most important thing I need to do is the quadrant. The quadrant is going to tell me how I should scale, so that's already done. And if you haven't done that, go ahead and do that. All right, the most important thing is the vertical shift. There is no vertical shift. I'm just going to assume that the midline is going to be on the x-axis. So that one's done. Lastly, we have a phase shift. We need to go left pi over 2. So I need to think, where should sine normally start? Well, sine normally starts right here at the midline, but it needs to move left pi over 2. So I'm going to move left pi over 2 starting here, and I'll do a different color just so you can see it better. I'm going to erase the other point just in case I get confused. All right, so then what I want to do next is follow the sine sequence. Sine is going to start at the midline and then go up to the amplitude to the next quadrant line. So that's going to be here, and then it's going to come back down to the midline. It's going to come down to a minimum at -2 and follow this pattern all throughout. So let's see if we can go ahead and connect that with a smooth curve. All right, so this right here is our sine graph. Okay, so then all we need to do is add those 2 caveats and we should be good to go. We know that the cosecant graph is going to have asymptotes anytime sine crosses the midline, which is going to happen here, 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 and here. We also know that cosecant is going to have points anytime sine has a max or min, which is here, 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 and here. Follow that up with that U shape that follows the asymptote, And you should get the following as the graph of 2 cosecant of 1x plus pi over 2. And that's the solution. All right, I think we have one more question to go. Okay, for this last question, we're kind of dealing with a secant graph here. Don't be afraid, it's going to work the same way. What we really need to do is we need to graph what does cosine of 3x plus pi look like. So go ahead and start by graphing cosine of 3x plus pi by first determining what the period, the quadrant, the amplitude, the vertical shift, and the phase shift would be. Okay, I figure I'd pause here because I want to walk through how to find the phase shift on this one. Okay, you should get a period of 2 pi over 3. To find the quadrant, all you need to do is take the period, which is 2 pi over 3, and divide by 4. Now, dividing by 4 is the same thing as multiplying by a fourth. So 2 pi over 3 times 1/4 is going to simplify, if you guys see that here, it's going to simplify to pi times 1 over 3 times 2, which is pi over 6. Our amplitude, on the other hand, is going to be 1. There is no vertical shift, and I want to walk through how to find the phase shift. To find the phase shift, we need to get x by itself. So I'm going to start by subtracting pi on both sides. So negative pi is equal to 3x. Divide by 3 on both sides, and it looks like we need to go left pi over 3. So let's go through and see if we can figure this out. Most important thing in our problem is going to be the quadrant. We need to scale by pi over 6. So we can scale by pi over 6. We could say pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, and continue on in that direction. So make sure you go in both directions with this. I don't really care too much if you simplify your scaling. It looks nicer, but sometimes, if you don't want to simplify it, I think we'll be okay if we don't. All right, so we're done with that. We went ahead and scaled it. Let's go and talk about our vertical shift. There is no vertical shift, so I'm going to assume that the midline is the x-axis. Okay, very last thing. We went left pi over 3, which means typically speaking, the cosine graph starts at a maximum, and I think I went up a little bit too high. It starts off at a maximum of 1, right, because our amplitude is 1. So cosine should start here, but we need to go left pi over 3. This is where maybe we should have simplified our fractions, and if you didn't, that's okay, because we can probably visualize what that means. 2 pi over 6 is pi over 3 because 2 goes into 6 3 times, and so we need to go left pi over 6, which is actually over here. And this is where we're going to start our graph. So maybe I erase here so I don't forget. Okay, let's follow the cosine function pattern. Cosine starts at a max, goes to a minimum, goes down to the midline, back up to the midline, back up to a max, and continues that pattern all throughout. And we're going to connect with a smooth curve. And so this right here is the cosine function, which means we're almost done. The last thing that we need to do is establish that every time cosine crosses the midline, we should have an asymptote. So let's go ahead and sketch one. Every time cosine crosses the midline, we have an asymptote. And every time cosine has a max or min, we're going to have a point for secant. We're just going to connect those using those U shapes. If it's a max, we go up. If it's a min, we go down. And the total graph for secant of 3x plus pi is going to look like the following. Okay, so that should be it for our notes for today. Please let me know if you guys have any questions. I'd love to help you out. Just send me an email.